So, yesterday we did 10-7, well, kind of the last 2 days, we did 10-7 day 1, which dealt with compounding continuously or exponential growth and decay. Unfortunately, some of those equations don't take into consideration that that'll probably tail off at some point, as Mr. Brooks would say, some kind of carrying capacity. Okay? The one we're going to take a look at today is much more of a logistical equation. It is going to tail off. It is going to try and follow a pattern that would actually happen in nature. Okay? As you can see, the formula is a little bit more intense than the one we had yesterday. But this could also be used, as you can see, for appreciation and depreciation. As they say, when you buy a new car, they say the second you drive it off the lot, it has depreciated in value. What that means is if you were to turn around and try and sell it back to that dealership, they would offer you less than you just paid for it. Okay, it has lost value. Now, cars can sometimes start gaining value again if it becomes a classic. Okay, but they basically say that, so things do lose value, right? Or just think if you bought a brand new TV about 4 or 5 years from now, it's not going to be worth what you paid for it. Right? Now, some things appreciate in value, sometimes jewelry. And one thing we hope appreciates in value but doesn't, well, we had a slight problem with that about 7 or 8 years ago, is houses are supposed to appreciate in value. They are supposed to gain value as time goes on. Okay? And so think of it that way, appreciate, depreciate. So depreciate is losing value if you have to add that next to the word there if you're not sure, if you think you might forget that, and appreciate is that it is going to gain value. So this value here stands for new value. That's why they put VN, new value. Or if you want to keep it the same as the other formula, it's the end amount. If you want to keep it looking the same as the other one. But if you can remember a new value, well, then that's fine. Probably no big surprise that P is the same thing it was. It actually stands for principal, okay? Or we could just call it the start amount. Now, the last few days we had E in our formulas, and E stood for E. Today we have a 1 in our formula right there, and it stands for 1. Very, very tricky how they do that, yeah. R, well, once we get what they all are, I know you say those is hard, but once we get it all in there, we'll get it. R is the interest rate. Again, if it's in the formula, though, you probably want the interest rate as a decimal. Very good. It'll usually be given to you as an annual interest rate, just like it was in the other formulas we had. N. Both of these are the same number. Okay, there's 2 N's there. Both the same number when you're in a problem. And N stands for the number, that's not a hashtag, all right? Number of times compounded in a year. And I have left just enough space for T. It is time, and in fact, time in years. So we could say number of years. There are many versions of this formula. I have given you the one that will work for pretty much any situation. Okay? Because sometimes N will be 1. And if N is 1, do you see how this formula could be much easier than it looks right now? N being 1 is much easier. But maybe N's 2, maybe it's 4. Okay? We're going to have to take a look at what it could be. Okay? The 1 is there because what it's going to do is it's going to add on top of what we already have. Okay? And I'll just give you a quick example. So let's say you bought something for $10. Right? You with me on that? let's say there's 5% sales tax. Do you agree that would be 0.05? You with me on that? I'm just going to show you why the one's on there, why this works. So why don't you find out what the sales tax is real quick on your calculators, if you need the calculator for that one. Okay, for those of us that are struggling a little bit, you would take $10 times 0.05 to find out what 5% of it is. For some of you who are not using a calculator, because in all honesty, you probably shouldn't have needed one. Okay, should be 50 cents, I'm guessing. Yes. So do you agree tax is 50 cents? So then if I had to find the total bill, it was $10, but I got to pay 50 cents in tax. So how much total do I have to pay? All right, do you agree 10.50? So here, hold on. I'm going to show you why the 1 is put on in this formula. Do you agree I had to do kind of 2 steps here? I had to find out the tax, then add it on? Just go ahead. Why don't you take 10 times 1.05? Do you agree that is a 1 put out front? It's basically 105% is what that's saying. So it's going to add the 5% on top of it for you. Okay? So go ahead, take 10 times 1.05. It's going to get you right to the 1050. See how it's not going to give you the 2 steps? Because it's 105%. Saying take 100% of it would be $10 and another 5% of it. Does that make sense? So that's why this particular 1 is in here, because it's going to keep adding it in for us. Or maybe subtracting it out if, you know, that exponent happens to end up negative or something like that. All right. So there's a lot of stuff written on here. Let's give it a try. Let's see what we can do. So the Jamesons bought a new house 5 years ago for $65,000. The house is now worth $117,000. Assuming steady rate of growth, what was the yearly rate of appreciation? Do we agree that it appreciated? It gained value, yes. So the rate should probably be what, positive or negative? Positive. If it lost value, it would be negative. Very good. So let's see what we've got here. In our formula, do you want me to do the VN or do you just want me to put A? I mean, it doesn't really matter to me as long as you know what that stands for in the formula. Which one would you prefer? V sub N? Doesn't matter? All right. So I'm just going to get it written in here. And let's see what we can fill in. Do we know the new value? What is it? Very good, 117,000. Do we know the principal or where it started? Yeah, what do we got there? 65,000. 1 is 1. Plus. R, yeah, it says what is the rate, right? So R is going to be what we're going to try and solve for. N says what was the yearly rate of appreciation. So how many times is it going to compound in a year? If I want the yearly rate, it's only going to compound once a year, so that'd be a 1. So that N right there was a 1. So then that N right there is a 1. Okay? And T is time in years, which is 5. Okay. So this would be one of those cases that did we really need the over N? No. But if it saves me from giving you 2 separate formulas. This way I can just give you one, use it. Okay? So now we take a look at this formula. I notice something right off the bat. But then I'm looking for something. I notice that there's no variable in the exponent. So am I going to need logarithms? I am not. Some people use logarithms no matter what. You don't need it here. It's going to make it worse. Okay? So now our job is to get the R by itself. Well, can we do that? Yeah. Multiply by R because R is 1. Well, what we're doing is we are multiplying this by 1 plus what the rate is because I want to add it on top of it, kind of like we just did in that last one. But what we want to do now is get R by itself if we can. So let's try and get R isolated. Is it isolated right now? It's got almost everything attached to it. right? So let's get stuff out of here. How are we going to, what's the first thing we should probably try and move? Not subtract, but yeah, divide the 65,000. Once again, as I said in the last few days, I try and keep it on my paper as long as I can, and then go to the calculator at the end, because then I'm not rounding, okay? So then right here, because this 65,000 times everything, so it just cancels, right? And then these zeros basically cancel, right? So I'm left with 117 over 65 equals 1 plus r to the 5th, once I clean all that stuff up, right, is r by itself. No. Well, we've got a 5 and we got a 1. What's going to be our best bet to get rid of what first? Yeah, probably the 5, right? Take the, well, that's to the 5th power. How do you get rid of that? 5th root. Ew. 5th root of that side, because you do have to take a radical of the entire side. You can't just pick and choose. I'm going to take a wild guess that the 5th root of 117 over 65 is not a very pretty number, right? But again, I'm going to try and wait as long as I can before I go to that calculator. So right now, what we're looking at, whoops, never mind, is the 5th root of 117 over 65 equals 1 plus r, right? We almost have r by itself, and then we can go type this into a calculator. Yeah, we just got to get the 1 out of there, so subtract 1. But then how does that work with this 5th root over here? Does the minus 1 go in the radical, or? Yeah, it's got to stay outside, yeah. So it's the 5th root of 117 over 65. That'll be some decimal my calculator will tell me, right? And then minus 1 will equal r. So this is what we've got to calculate. Okay, so I'm going to go to the calculator, and we'll see what we can do. So all of you try this as well to make sure that we know how to type it in. Now, I will show you how to get the 5th root on a lot of the calculators. On this particular one, it's under math, but it is the same looking button that you're looking for. You're kind of looking for that button. On the TI-30s, I think it's above the caret key. It has the X and then the radical on it like that, right? So what we're going to do, though, is I'll use that one. So I'm going to quit out of here because I'm in a program. It was the 5th root, right? So you type the 5, because I know it's going to be 5th root, and then you type that button. So see how mine just automatically became the 5th root. Yours isn't going to do that. Yours is going to kind of look like this. 5, and then that button. That's what yours is going to look like. But trust me, that 5 is taking the spot of that X. Okay, it just doesn't look the same as mine does right now. Okay. So 5th row, was it 117 over 65? Is everybody able to find that button that I'm talking about? Now you have to make sure that you don't take the 5th root of that minus 1 as well. So you got to either close off that parenthesis or whatever it gives you there. So then minus 1, right? This should be r. Okay, is it going to be r in decimal form or in percent form? Decimal form. Okay. So I want to make sure everybody gets that for r. So I'm going to leave that up there, and I'm going to come around. And so we're going to pause the recording here for a second just to see if you're all getting that. All right, so we did have some with the calculators that they kind of have to type them in the reverse order, but it seemed like they kind of figured that out. But remember, you do have the option on this one of just typing in 117 over 65 caret 1/5 power. That's how some people like to type it in. They don't even want to mess with it. That is the 5th root of 117 over 65. That's what that means. You just have to make sure you have parentheses in both locations. Otherwise, it's not going to give you what you want. Okay? So if we go back to our calculator, then this would end up being moved over twice. So we're looking at, what, about 12.5%? Because I don't think the problem says word around, does it? No? So 12.5%. Okay. And there was a very long time that houses did gain about 12% every about 10 years. Okay? And then, of course, there was a slight problem with that. And so that is not what they're gaining necessarily anymore. So we decided we're going to go with 12.5%. Okay. So any questions on that one? Okay. So it works for appreciation and depreciation, but it also works for things if they are compounded at certain intervals. Compounded means how often you get the interest. So if I invested $1,000 at 2% annual interest compounded quarterly, so that's how many times in a year? 4, yep. Then when will the investment be worth $2,000? This is almost the exact same problem I gave you on the other sheet of notes, except we did compounded continuously. Okay. You would think there would be a huge difference between the two, but there really isn't, because the annual interest rate's the same. Okay. So here we go. Let's see if we can figure out what goes where. Do we know the new value? 2,000, all right. Do we know the principal or the beginning value? 1,000. I got the next one. It's 1. Plus, now we got the rate. 0.02, very good, because that's 2% right there as a decimal. 0.02 divided by n, which is not 1, it's 4, because it's quarterly. So what they're doing is they're taking, really what they're doing with this division is they're taking the rate and finding out what the rate is at each compound. That's all they're doing here. It's 2% for the whole year, but I get it 4 times throughout the year. So at each one, that's what it would be. Okay? And now, if this one here was a 4, that one up there has to be a 4. I don't know why I changed markers. All right. And T. Oh, yeah, we don't know. T. And just like the last problem, I'm noticing something pretty quick here. I think we're going to need some logarithms this time. Yeah, there's a variable in the exponent. Now, when we had e in the other problems, natural log was our best choice. Okay? You can still use natural log. I don't think there is a great choice here. Okay? So you can either use common or natural because they're on your calculator. But let's get that variable as alone as we can. So let's do the same move we've been doing these other days, and let's get rid of this number out front here. Let's get rid of that 1,000. Right? So that's 2, unless you really want to keep writing all of that. So 2 equals, well, wait a minute. Last time we had a bunch of variables in this parenthesis. This time we don't. Can we just go figure out what that is? Yeah, why not, right? 1 plus 0.02 divided by 4. Let's figure out what that is. I bet you it's 1 point something. What do you got? 1.005 is correct. To the, 4t. So once again, I don't think there's a really exceptional base to use right now. So let's just, what do you want to use, common log or natural log? We'll do both. Well, I think we should pick one or the other. Common? All right. So take the common log of this side. Do you want me to take the 2 steps to move stuff on the right-hand side, or just go? Okay. So because of the logarithm, the 4t would be allowed to come out front. And you said common log, so we're going to do that. Maybe I'll put that even in parentheses there. So at this point, we have to get, well, t by itself, right? We could divide by 4, and why don't we just bring the log of 1.005 right along with it? Because we're going to have to divide by that anyways, right? Now, that's going to bring us to another thing that you have to be very careful with on your calculator. So let's divide by, whoop, that's too many zeros. Let's just divide by all of this while we're here. Because if we do that, t's by itself. But we're going to have to be really careful how we type that into our calculator. Okay, I'll wait till everybody seems to kind of have that written before I switch over to the calculator. We got it? All right, so log of 2. So common log, you said, right? Okay, log of, well, here, let's clear off this other stuff here. Log of 2, something really important right now. I got to close that off, or it's going to, whoops, I'm going to close that off, or it's going to keep taking log of 2, divided by, and now there's actually something really important that you need to type. You need to type a parenthesis. 4 log of 1.005. This parenthesis I just typed closes off the logarithm. The other parenthesis closes off that. If I don't put that, it's going to divide by 4 and then multiply by the log of 1.005. Is that what I want it to do? No. I want it to divide by all of that, so I have to tell it to divide by all of that. And that's what those extra set of parentheses do. This one here and that one there. Tell it, divide by all of that. Okay, so go ahead. Once you're that far, I'll wait for a second there. We're able to figure out how to get that one on there backwards. That one might be tricky, yeah. I would divide by the 4 separately, maybe. Might be easier for you. So my calculator, I got 34.7439, as you can see there. So about 34.7, it would be years though, right? Yeah. Okay, were you able to get it with the backwards typing? How about anybody else having questions? No? Everybody good? I can help you in a second, all right, with your backwards calculator. Because there are times that it's actually beneficial to have that one. So let's get started on the next one for now, and then I'll come around and help you with that. There, just so that you all do know, oh, maybe not. I thought there was an extra example today. I lied. Oh, yeah, there is. There is an example, extra one. So leave some room at the bottom. There is an example 5. If my son puts $100 into an account and has a 4% interest rate compounded annually, then how much will he save after 2 years? I think I'm going to have you try that one right now. I'm going to pause the recording. And if you are listening to the recording, I strongly recommend you also pause it instead of just continuing to listen and getting the answer. So I'm glad, as I was going around helping people, we found some common mistakes here. As you can see, I put the formula in there again and entered the information. What we were missing this time was the new value. We knew 100 was put in. We knew it was 4% annually. That's why we have 0.04 over 1 right here. And then, again, this is 1 times 2. Don't think that's a 12. All right, if you take it at the 12th power, that might not work out so well for you. All right, and plus, once you get here, you have to do an order of operations. You can't multiply, then take it to a power. Okay, you have to do the power first, then multiply. Or what a lot of people do at this point is, in all honesty, they just type it straight into their calculator just like that. Okay, and if you do that, I believe somebody said 108 something. Isn't that what somebody said? $108.16. And then there were also the discussion of, even in all reality, that's a little over $8 in 2 years for only giving the bank $100 bucks. Do you think the bank made $8 off of your $100 in those couple of years? Probably not. So is that an acceptable, or is that a believable interest rate? Yeah, not really. You're like if you get 1. Yeah. Yeah, it's less than 1%. Yeah. We would like it to be that, right? But it is unfortunately not. So, yeah. Yeah. You're not going to make that much. No. You might make that much if you give them 10 grand. All right. An account gives you 2.5 interest compounded every 2 weeks. I made this one up just to see if you could figure out how many times that was a year. A lot of people mess that up. If you ended up with $2,100 at the end of 4 years, then how much money did you put into the account at the beginning? So of this, we've got our formula again. Do I know the new value? What is it? 2,100? Are we all in agreement of that? Okay. Do we know the principal? How much was put in? We do not. So this time we're solving for something different. 1 plus, what is the rate? Who's got the rate here? 0.025 is correct. Over. Now, here's the end. A lot of people think every 2 weeks, oh, they think, hey, there's 12 months in a year, there's 4 weeks in a month, that's 24 payments. Okay, unfortunately, there's 52 weeks in a year, so if you get paid every 2 weeks, that'd be 26 payments. All right? So, unfortunately, that 2.5% is getting split up over 26 payments, and 26 times 4 because it's 4 years. All right? So now we have to take, again, where's the variable? And then decide, are we going to be needing logarithms here? And no, we don't. There's no variable in the exponent. And that's why I keep going different types of problems to see, you know, where you're at. So my suggestion is, why don't we go figure out what's that? That's all times p, and then I can divide by whatever that is, and we've got it. Okay? So let's go ahead and why don't you try typing that into your calculator. I'm going to wait a second here until I see that everybody's kind of got that written down, and then I'll type it in and see what I get. And then I'll show you how to kind of use that number without having to round. Is everybody ready for me to go type it in? All right. So let's get rid of that. Okay, what do we got here? 1 plus 0.025 over 26. How come I didn't put like parentheses this time? Because would order of operations do this properly? It's going to do the division first, and then it's going to add the 1. Yeah, it's going to have 1, and it's going to wait to do that division and add it in there. So that'll work. And I want to take that, well, 26 times 4, 104. So is everybody okay if I just do the caret 104? Okay. Again, yours doesn't quite do it that way, but it just puts the caret and then writes the number, right? I think it even gives you parentheses, doesn't it? So this will give me the number that we're, one of the numbers we're looking for. Well, that's not all that pretty, is it? No. That is not P. No. Okay. So let's take a second. Everybody look at what I got typed in. Let's figure out where that is. Okay. So let's go back. That is the stuff I have in this rectangle here, this black rectangle. So that's times P, right? I'm going to have to divide by all of 2,100 by that, correct? Everybody see where that's coming from? So let's do that on the calculator. Let's take 2,100 divided by that on our calculator. But let me show you how to do that. I know I've showed you once before. Just take 2,100. If I could just somehow get that number down here, that'd be amazing. Okay? And if you hit second and, yeah, like the opposite button here on the bottom, it'll bring your last answer. But make sure you hit divide first. I almost hit it without hitting divide. That would not have worked. Okay, divide. Second, and then this little thing is answer. It brings back whatever the last answer was and puts it down there. And, yeah, you click enter, and there you go. Okay. And so we would round that, what, to $1,900.25. All right. I don't think we're going to have enough time to finish this one today, but at least you can get it written. I did this one after I had printed everything. It will be on next year's. So why don't you take some time? I think the bell's going to ring on us. We'll finish it up. Yeah, probably. Well, we'll try. So why don't you get it written down? We'll see how much we can get done. So 6 years ago, I bought a baseball card for $5. It's now worth $43. Assuming a steady rate of increase, what is the yearly rate of inflation or appreciation for the baseball card? Yeah, it's not bad. But I'm looking for the yearly rate, not the overall rate. Is the rate going to be positive or negative? Positive, yeah, it went up. Yep. Yeah, it's probably a good idea to at least write something down. Otherwise, you're just going to see a bunch of numbers on your paper and not know what it's about. You know? Oh, yeah, those are awesome numbers on my notes. I don't know what they're about, though. All right, do we know the new value? Yep, 43. Do we know where it started? 5. 1 plus, don't know. And it wants, to, again, the yearly rate of inflation. So, yeah, 1, 1, and 6. So this is very similar to the one that we had earlier, right? So why don't you go ahead and solve. It might be a little higher percent than you were had on the last one, though. Again, probably divide by 5 first. We're going to need a logarithm. Nope. Right. 6th root then, right? And then subtract 1. We'll see if you remember how to type in the 6th root. Yeah, it's a higher percent than you maybe are expecting. But if you're starting at $5, 100% increase in a year would be up to $10. And then another 100% would be to $20, right? Another 100%, you know, does that make sense if I say it that way? 100% increase is doubling. All right. What I got was, in percent form, 43.136%. Okay. Sorry to push through on that last one, but I did want to get the recording done by the end of the period, so hope I didn't rush you too much on that one.